All right, so let's talk about simulation. So, what exactly is simulation? This picture briefly highlights what is simulation. The picture on the left in the back shows you a mannequin which acts as a human. It's a replica of a human body, and it can simulate the actions or problems of a human being, of any human being. So this mannequin may have heart problem. It may have a fast beating heart. It may have irregular heartbeat. It may have issues with the stomach, and all of those problems that a normal human being can have can be replicated in this mannequin, and the doctors are assigned to diagnose the problem that is simulated in this mannequin. So that's how simulation is being used or can be used in a physical form in a hospital. Right in the center, this very excited gentleman looks at a computer screen, but he sits upon a hardware that completely transforms his experience of the screen. So when he turns, the seat will turn along with it, and you'll get an immersive experience of the gameplay that is playing. On the far right, we can see a very famous computer game called Counter Strike, where it's a first-person shooter, and the person who is playing this game will feel an immersion of being involved in a war-like situation, being a terrorist or a counter-terrorist. But whole point is that you can actually simulate. In this game, you're simulating a warlike situation, a fighting situation between two groups. So that's how computers and real world around us can be simulated using a replica of that original model. And in the upcoming videos, you will gradually be able to understand that how a business can actually simulate their system and then use that simulation to solve the problem rather than actually going after the systems in real world, which could be which can be costly, it can be risky, and you'll actually I'll share with you the case studies and the results which show that if this a certain test of a problem was conducted in real life, that would have been very costly. So, simulation, by definition, is the imitation of the operation of a real world process or a system over time. So, this means that obviously, if you're a company, if you're an organization, or like in the systems, like the examples that we just saw. So, when the time changes, you have a process or a system that evolves. So, we can imitate, we can replicate, we can model that system in a computer. Not necessarily a computer. You can actually use, like I said, a mannequin in a hospital to replicate that system over time. Where, other than the hospital and the gaming examples, where can this simulation be used? It's used in safety engineering. You must have seen on various TV shows that there's a crash test of a car. Now, what that is test is doing, it's replicating and imitating a real life situation of an accident, which eventually helps the companies, the organizations, the engineers, the scientists to develop better safety protocols, to develop better safety systems for that car or design for that car. So that's safety. So simulation is used in safety engineering as well. Then we have testing. So the testing can be for any purposes. Like I said, for the crash test, that is a simulation. But other than that, testing is a very generic word because that involves mock tests that we perform for example, taking our GRE or a TOEFL. The entrance examinations are replicated and simulated using softwares that you can download in your computers and have a mock test in your home or in a test center. Similarly, you have a similar test situation in many other industries. Then for training purposes, so simulation is used for training as well. For example, the flight simulators that we have for the aerospace engineers or the people who are involved in taking courses of flights, flight pilots. If I want to become a pilot, I join a course. They put me in this trainer, a simulated trainer, which will train me on different big and small airplanes, for example, Boeing and the others, and they will give take me through various different scenarios, whether it's windy, cloudy, or it's a difficult flight, and how I'll land the airplane, how I'll take off. So all of that will be involved in training. Similarly, like I just showed an example of uh, the Counter Strike. So you have a warlike situation. So you can imitate that in a computer as well. Then for education purposes, so today YouTube is filled up with various kinds of poems. We have lectures, we have animations, we have cartoons. We also have what we know as MIT App Inventor. So softwares like these help us to imitate real world scenarios in a computer simulation, and that helps in us in educating a lot of population in the world now. So you have young kids, and you can make simple animations, cartoons to teach them about life lessons. You can teach them math, you can teach them physics, engineering, whatsoever. And lastly, obviously, the video games. And this list is just not limited to it. There are a lot of things to it. So, why simulation? Simulation particularly helps in experimenting the what if questions in the virtual world to create the optimal solution for real world. So if I say that if I want to test that if I jump from 100-meter height, whether I'll break my knee or not, or whether I'll survive it or not, instead of really going out to that height and jumping off the cliff, I could simulate myself jumping off that cliff, and with all the parameters involved, I can see what are the results going to be. So, what if I jump from a cliff? What if the process that I have in my industry, what if I change or move a certain machine from one place to another? What is that going to do to my system? These are the kind of questions that we can solve or answer using simulation. The simulated models exhibit dynamic and stochastic behavior not possible to accurately judge in real life scenarios. So, in real life scenarios where we don't have measurements, we do not have data, we are completely relying on a self intuition. We're relying on our own experience. We're relying on the statements of people who are surrounding us who may have a lot of experience in their fields or domains, but still they do not, you cannot quantify their experience. The only way you can quantify them is through probability, through statistics. You can take data out of those systems and then simulate those models. And when you have very sophisticated mathematical models that will be backing up with that data, the models that we are going to simulate is going to be very dynamic and very accurate as compared to the real life scenarios. What gives what is the advantage out of this? You will be able to come to the best choice, the most optimum choice for your system. You can also, using computers, we can also manipulate the time periods. So, for example, a worker or a supervisor in your industry may be very experienced, and he may be able to answer to your question that whether if I shift this machine from that point A to point B, whether it's going to solve my problem or not. Based upon his experience, that he would say that, okay, yes, it's going to solve for a couple of days, but then you'll have to shift it back to the point A. That's based upon his own experience. But if you have that scenario modeled in a computer,